Okay, in this video we'll take a look at the conclusion to problem number 69 from out of section 3.3, and just to kind of recap what the problem was all about. We had a person standing X feet back from a wall. Their eye level was 5 feet above the ground. A painting had its bottom 6 feet off the ground and its top 8 feet off the ground, so the painting's 2 feet tall. And what we wanted to try to do is we wanted to try to figure out how far back from the wall this person should stand in order to make the viewing angle that they're seeing this painting at as big as it can possibly be. So find the absolute maximum value of angle A. And so what we attempted to do was we attempted to develop a formula for angle A involving this diagram over here. We eventually developed this formula for angle A, and we wanted to try to find the value of X that would make angle A as big as it could possibly get. And since A is written right here as a function of X, we are trying to find the value of X that gives us the maximum, the absolute maximum of the function for A. So we took the derivative of this formula using the chain rule, and we got to this. And what we were going to try to do is we were going to try to figure out when this derivative was equal to 0 and figure out when this derivative was undefined, trying to find the critical numbers of this derivative. And what we're going to need to use in order to do that, you could try to do some simplification algebraically here, and this will simplify quite a bit, and it's possible to do this without a calculator, but I chose to go ahead and kind of show you how this would work on the calculator. So what I did was I graphed this derivative. I'm not graphing the function A, I'm graphing this derivative on the calculator, and on the calculator you don't really see a whole lot. You see something just above the origin there that starts to kind of get graphed in. We want to find the value of X that makes A as large as it can get, and right now we have the derivative of A graphed. So what I'm going to do is I'm just going to try to manipulate my viewing window. I don't want my X values to be below 0. I'm not going to have a negative distance back from the wall. I don't think I'm going to have to go much more than 10 feet back from the wall, so I'm just going to leave that be a 10. I saw that graph didn't really drop below the x-axis much, or the y-axis, excuse me. No, x-axis much at all. So I'm going to make y min -1, y max. It got up above the origin a little bit. Maybe I'll make y max 3. I'll just go ahead and I'll regraph, and I see something like this. And keep in mind, this is a graph of the derivative. So the derivative looks like it's above the x-axis initially, and then it drops below the x-axis, and it looks like it stays below the x-axis. And just to kind of confirm that, I'm just going to quickly take a look at the table of values here. And if you look at the table of values, you actually have an error at 0, but we know that 0 is not going to be the value of X that maximizes this, because we're not going to stand 0 feet from the wall. We won't have a viewing angle then. So we see a positive value for the derivative at 1, and then negative values for the derivative from that point onward. And it looks like the derivative is going to stay negative as we let X grow and grow and grow. So it seems like the value of X that makes the derivative 0 is whatever value of X it is right here where the graph crosses the x-axis. And so if you go ahead and use the 0 feature from the calculate menu to find it, just let me get back over to the left of the 0. And that should work. And then over to the right of the 0. And I think I'm to the right of it now. And then give it a guess. And so the calculator should, yep, there it is. Calculator gives us a 0 of 1.732 feet. So if X is about 1.732 feet, we know the derivative is 0. So that's a stationary point for us. Now we did have that one singular point, the one value that made the derivative undefined, and that was 0, but I'm not really going to consider that because the person's not going to stand 0 feet back from the wall. So I'm assuming that this is going to be the answer. We could confirm that by making a sign chart, but the nice thing about having the graph of the derivative on the calculator, think about what happens to the derivative as we go across this 0. The derivative is positive to the left of this 0, it's above the x-axis. The derivative is negative to the right of this 0, and by derivative, I'm not talking about slope of the tangent line on what you're seeing graphed. This is a graph of A prime, or of dA dx. And dA dx is positive to the left of the 0, it's negative to the right of the 0. Therefore, our function for A must go from increasing to the left of the 0 to decreasing to the right. And since the function goes from increasing to the left of the 0 to decreasing at the right of the 0, that x value that made the derivative 0 must be the value that gives us our maximum.